The Sky This Month with your host, Dave McDonald.
Welcome to The Sky This Month. I'm your host, Dave McDonald, and we are talking about the second half of June 2022. And you know what awesome event happens in the later part of June? We have the summer solstice. Yay, summer is coming at 5:13 a.m. Eastern Daylight Time. We have some great things to talk about. The planets are still in alignment in the morning sky. At the end of the show, I'll be showing you that alignment and what you can look for and what you can see in the morning sky. And then some great constellations to look at in the night sky. Seth Roop is going to be our guest today, and I'll be introducing him to you in just a little bit. And we're going to talk a little bit about the solstice to start with. And so you can see behind me is an image of Stonehenge. And so if we can bring that to the foreground, we'll take a look at Stonehenge, and you can see the sun coming through the stones there. And that is set to happen on the solstices. There's another phenomenon that's set up for the equinoxes, but for the solstices, the winter and the summer solstice, there's a certain alignment of the stones. But one of the neat things that I was able to do is check this out. You ready? Watch this next slide. Can you believe it? I was there at Stonehenge. And that's not the most flattering picture of me, but it's just was handy. And it was just so neat to be there, to spend an hour plus walking around, looking at the different alignments that there are. And one alignment in particular that was pointed out was this one here along the walkway. That's called the heel stone, and the heel stone is lined up. You can see in the background the stones that are set up, and on the sunset of the winter solstice is when the sun will shine through those stones. And that arrow is just marking that, going, just grazing by that heel stone towards where you see the stone set up is where the sun is going to set on the winter solstice. They didn't have a marking set up, and I didn't have much luck researching where the sun pops through for the summer solstice, but where we have coming up. But just kind of an amazing setup of stones, heavy stones, lighter stones, blue stones that were brought from near and far. And another interesting thing about the stones that you may or may not know is you see the stones that are sitting on the top. There's actually kind of like a tongue and groove, or a ball and socket, if you will, that the tops of the uprights have circles in them, and the stones that are laying across the flat have like a ball that's going to fit into those carved out semicircles. And it's really amazing. How did they get the stones there is a question, and then how did they lift them on top of each other to get them there? So, great story. I'd encourage you to look up the story of Stonehenge. But the important point of mentioning Stonehenge related to the solstices and the sun and all, I want to bring up this next image. So this is the orientation of the sun on June 21st. This is solar noontime. The vertical line that you see right here, this vertical line is the meridian. Okay, so that is when the sun is on the meridian, which is a line that connects due south to overhead, the zenith position, to north, is called the meridian. And when the sun is on that line, we call that solar noon. So this happens to be the 21st. Remember, the actual moment of the solstice happened at 5:13 in the morning, and this is noon plus or minus. I think it's like a little afternoon. But the point that I just want to bring out is that this line here is the equator, represents the equator, and that is what would be directly overhead if you were in Ecuador, which the equator runs through. I think Quito, Ecuador, and such. but the sun is as high as it's going to get for the entire year above the equator. And even though it marks the beginning of summer for us, and we start to enjoy vacation the end of June and July and August and all that, but the sun after June 21st, actually after 5:13 a.m. on June 21st, the sun is going to start making its way southward towards the autumnal equinox. So just wanted to point that out. And so if you had a measuring device, the sun is roughly from the horizon up to where the sun is. Don't look at the sun with unaided eyes. You want to be sure you have eclipse glasses. If you want to look at the sun, just regular sunglasses won't do the trick. But the angle is going to be about 71 to 72 degrees above the horizon. So that's kind of cool. So if you look at this next image, you see the sun is in the middle, Earth is here, and we have on the left side the summer solstice, and you see that the rotational axis of Earth is pointing towards the sun. And then for the winter solstice, you see the rotational axis of Earth pointing away from the sun. So the southern hemisphere gets the more direct rays, and in the summertime for us in the northern hemisphere, we get the more direct rays in the summertime as the polar axis is pointing more towards the sun. And then the sun is right over the equator on the vernal and the autumnal equinox. So I want to introduce to you Seth Roop again, and we're going to chat in just a little bit, but welcome to the show, Seth.
Pleasure to be here. Thanks for having me.
It's always nice to be had, or something like that.
Something like that.
So Seth's going to help me put some props up on the tables. He's going to put up the sun, and I'm going to put up Earth. They are nowhere near proportional in size, and because of the size of our table, they're nowhere near proportional in terms of distance. It's just for illustrative purposes. So Seth, you get the sun, I'll get Earth. And we haven't found the daughter yet. So now if we can kind of get a close-up here. This is the equator, right? This is just your typical globe that you would have on your coffee table. And here's the equator. And then a close-up that you'll see in a moment. This is the line called the Tropic of Cancer right there. But that's the Tropic of Cancer, which is 23.5 degrees north of the equator. And you can see how the rotational axis of Earth is pointing towards the sun. And at this position, we have summer. Then as Earth would go around the sun over in this position here, we have the autumnal equinox. And Seth, you can take it over there, bring it around. Notice that the rotational axis is always pointing in the same direction towards the North Star, towards the star called Polaris. And that would be winter for us, summer for the southern hemisphere. And I'll take it around the other side, and we have here spring again, and now we're back to here. But the important thing I'm trying to just point out is that the rotational axis of Earth is always pointing in the same direction. It's pointing towards a star called Polaris. It's about 3/4 of a degree off of dead center. And the sun at 5:13 a.m. is going to, so to speak, bounce off of the Tropic of Cancer. The sun is on its way north as Earth moves around the sun. And then at 5:13 a.m. on June 21st, it's going to just kiss the Tropic of Cancer, and then it's going to start making its way southward towards the equator, which it will cross in September. Next slide to show is what I was talking about, the tropics here. So the direct sunlight coming in, this is the June solstice, and you can see the direct sunlight, and it's going to hit the Tropic of Cancer. The winter solstice, it's going to hit the Tropic of Capricorn. So those two places, just once a year, at the Tropic of Capricorn and the Tropic of Cancer, just once a year on the solstice, is the sun directly overhead. If you live north of the Tropic of Cancer, or if you live south of the Tropic of Capricorn, the sun is never going to be overhead. If you live between the Tropic of Capricorn and the Tropic of Cancer, then the sun will be directly overhead twice during the year, once on its way up and once on its way down. So, pretty cool stuff. Here you can see the sun coming from the right of your screen. The sun's rays are hitting the northern hemisphere directly on. The rotational axis is 23.5 here. It's more specifically, it's like 23.44 degrees. And you can see the equator and the rotational axis of Earth right here. And you have the Arctic Circle on the north. And the Arctic Circle, that's the boundary that's marked off during the solstice, the edge of where the sunlight is. So during the solstice, the entire Arctic Circle is in 24 hours of sunlight. And likewise in the winter solstice, the Antarctic Circle on that solstice day, the entire Antarctic Circle is in 24-hour sunlight. So pretty cool stuff. So don't miss it. For whatever reason, I would just encourage you to be awake, set your alarm clock to be awake, just to be conscious at 5:13 a.m. Eastern Daylight Time. You can correct that for your time zone if you're watching elsewhere. And just notice, oh, I can feel it. The sun just bounced off that Tropic of Cancer. One of the neat things that's been going on since the launch on Christmas, Seth is going to talk a little more about the James Webb Telescope. We're trying to give you a little bit of an update every month as to what's going on with it. So Seth, please tell us what's going on with James Webb.
Yeah, so of course James Webb has been hotly followed and is a subject of interest for many people as a successor to the Hubble Space Telescope. And it launched not too long ago on Christmas, as Dave just pointed out, about 6 months ago now. And it was a very difficult process, a lot of engineering going on to get this thing to where it is now, but it went very smoothly. In fact, they even have surplus fuel from the maneuvering operations they used to get it to where it is. So it is expected that the telescope will be able to operate for even longer than they initially planned. And initially the mission was intended to be operational for at least 10 years.
Right.
But the surplus fuel can allow them to have extra fuel, so it may be able to run longer.
Right, and the fuel is really important because it's not like it's just out there in an orbit, but it has to keep a certain orientation towards the sun, towards Earth, towards what it's looking at, and it takes fuel to maintain that orientation.
Yeah, and you're not driving this thing up to the pump and filling it up.
And
so
no, nobody's going out a million miles.
Yeah. So the telescope is getting ready to be fully operational to start conducting measurements and taking pictures and doing lots of awesome science. Part of that process involves cooling the devices on board the telescope. There's lots of infrared tools and near-infrared tools, and they need to be extremely cold to be running. And it takes a very long time to get things that cold, because we're not talking about it's cold out like it's a little bit below zero. We're talking about negative 250, negative 280 degrees Fahrenheit, freezing cold temperatures.
Yeah, approaching absolute zero.
And it takes time and energy to get things that cold. So, and all of this equipment is very delicate and expensive. So, definitely want to be careful, not rushing things. So, they're cooling instruments and then aligning mirrors, and we're hopefully expecting to see color images coming from the telescope sometime in July. So definitely look out for that. It's going to be really, really incredible to see what we get from these new technological advancements.
And you mentioned infrared, and the fact is that one of the great things about infrared is it cuts through so much of the gas and dust, but in particular we're going to be looking at the near-infrared part of the spectrum. Seth, what's the reasoning behind that?
So we have near-infrared and infrared, and they seem very similar. The focus on near-infrared is coming from the fact that near infrared is just beyond what we can see with our naked eye in the visible light spectrum. So as a result, those wavelengths, which are only a little bit shorter when you're in the near infrared range, respond very similarly to certain types of like hardware and software, so that you can use lots of imaging and tools that are compatible with visible light with near infrared. And like you mentioned, it cuts through cosmic dust, and it makes us able to see things that we would not be able to see with visible light.
Which is awesome, which is one of the whole big reasons for being there. From what I remember just days ago, before our recording the show here, it seemed like there was a report of a micrometeoroid hitting one of the segments. Remember, there's 18 mirror segments designed to work together. So what happens, Seth?
Right. So where the telescope is out in orbit, very far away from space, or very far away from Earth, excuse me, and out in orbit there's lots of tiny particles of dust and rock flying around very, very, very quickly at speeds of up to 20 miles per second, which is rather fast. And even such small objects that could seem harmless, when they're going that speed and they make impact with tools and equipment, they can cause some damage. You can see on the right here is an image of impacts from micrometeoroids on solar panels. And that kind of damage can be very impactful when it's done to very sensitive equipment that needs to be very precise and exact. So that's something that the scientists who've been working on this have been very concerned about and very aware of, how micrometeoroids might affect the measurements that they're taking and the science they're trying to do.
And from what I remember, the report back after having realized this happened was that even though we've got this little defect now on one of the 18 mirror segments, it's still performing better than projected.
Yes. They've accounted for a fairly large margin of error relative to, this is an expected issue that they've been planning for. There's really not a way to avoid these microscopic particles from colliding with something. That's just a reality of having a telescope in space. So they're designed to be as resistant as possible. They're designed to adjust themselves if they're knocked out of alignment. And this is anticipated. So NASA is always very optimistic. So they tell us they'll be able to continue operating and continue doing what they're doing without much impact. No pun intended
so
there.
this next slide shows some micrometeoroids.
So you can see the impacts themselves are very, very small. We're talking about like tiny, tiny objects, a couple of millimeters and smaller across, and they're moving at such velocities that they can puncture right through little sheets of metal or solar panels and damage instruments aboard telescopes. So it is very much of interest to the scientists to be watching out for this and understand if the telescope is taking damage or being thrown out of alignment by these events.
And as we said, it's good that so far, so good. We're still operating above anticipated parameters, so that's awesome. So what are some applications of the James Webb Space Telescope, Seth?
So the infrared light, like we mentioned earlier, allows you to see a lot of things that are not as visible or not visible at all to the naked eye in the visible light spectrum. So we're able to see some stuff that is very, very dim, very old, very far away because of these sensitive cameras. So trying to spot galaxies and stars that formed very close to the beginning of our universe right after the Big Bang, that is something that James Webb can help with a lot by taking these very sensitive measurements of dim light over a very long period of time. We can start to see stuff and understand stuff that we haven't really before and can give us some insight about the beginning of our universe.
And as we look at the images here in the upper right of this slide here, we've got three images, one from WISE, one from Spitzer, and the last one on the upper far right the James Webb Space Telescope, and look at the difference in clarity.
Yeah,
And-
it's pretty incredible.
And this is just trying to get things aligned, just trying to calibrate
Yep.
things. This is not even like official science
Right.
images.
So the improvement from previous iterations of infrared and near-infrared telescopes is pretty marked. That's going to be really awesome to see. Even as casual astronomers, casual enjoyers of astronomy, just being able to see these beautiful high-resolution pictures, it's going to be a real treat. And all the other technology that is being used on this telescope has never really been done before, and it sort of sets the precedent for what we can do when it comes to telescopes and observations in space going forward.
So we will stay tuned to what's going on in July when we get some official science color images back. It will just be incredibly awesome. Just as a quick look ahead to July, because we don't want to miss out on the supermoon coming up. Seth, what is a supermoon?
Well, supermoon, some might say it's a deceiving term, but a supermoon is basically when the moon is as close to Earth as it's going to get, which is called perigee. And naturally, when the moon is closer to the Earth, it's going to look larger than if it was at its furthest point. In this diagram here, you can see an illustration of the size comparison between the moon when it is at its closest and at its furthest point. And there is definitely a noticeable difference. In my personal experience, the most noticeable difference when you're looking at a supermoon is the brightness. You might not be able to necessarily tell if it's that much bigger, but the brightness I find is definitely more noticeable. And a full moon is always a great time to just break out the binoculars, just step outside, take a look, and just appreciate the beauty of the moon.
And you may remember, Seth, years ago in pre-calculus, we calculated the difference in the size and the brightness, and it's just it's neat. It's neat.
It's really cool.
Math is fun in all aspects of our universe, for sure. Okay. Well, Seth, thanks so much for being part of our show.
My pleasure. Thank you for having me.
As always, and we'll look forward to having you again for sure.
Thank you.
Thank you. All right, let's have a look at what's going on in the morning of the night sky, and then some constellations too. So what we're looking at right now is the morning of the solstice. Remember, the solstice happens at 5:13. What I'm showing you right now is 3:45 a.m. on June 21st. And I'm going to show you a little bit about the alignment of the planets. So you can see Saturn here, and Saturn again rises about 1:30. So if you're looking at Saturn, you can see it a lot sooner than 3:45. This line that I've left up here is called the ecliptic. This is the path of the sun, but because we are on Earth, it's the apparent path of the sun around the sky, when it's actually the path of Earth around the sun. But we're on Earth, so it looks like we're tracing the path of the sun. But interestingly enough, that's also pretty much the path of the planets. The planets stay, including the moon, stay within 5 degrees of this line called the ecliptic. So Saturn, very easy to see in the morning sky. Not anywhere near as bright as Jupiter. And remember, right now we're in June 21st in the morning. The moon, this is going to be a pretty morning of the solstice. The moon is handy right nearby. Looks like a full moon here, just the way it's shown in this illustration on this slide, but it's really very crescent type of a moon. And as we move on in a moment to next week, we're going to see it become even more crescenty. And then right near Jupiter is the planet Mars. Mars is reddish in color, and it's just to slightly lower left of Jupiter, easy to spot. And a little later, I'm going to show you a star in Scorpius called Antares. And the name Antares, that I'll probably mention later, means I'm not Mars, because the star Antares and the planet Mars have very similar brightnesses and very similar colors. And then, as I step off the screen here, we have blazing Venus just rising around 3:45, and you can't miss it. So let's go on to the next slide, and we're going to we're on the same date. We're still at the morning of June 21st, but we're a little later. Now we're somewhere around 4:15 to 4:20 in the morning. But you can see the moon is still hanging out near Jupiter, and we have Mars. And Uranus is just not, you need binoculars to find it, and particularly in the glare of the sun, it's going to be difficult. But one nice thing is it's pretty much right on the ecliptic, and Venus. And then I wanted to show you, ta-da! Mercury is joining the show in the alignment of the planets. Isn't that cool? The answer is yes. You have Mercury, Venus, that you can see very easily, Mars, Jupiter, Saturn. Look down, there's Earth. You can see 6 planets on the morning of the solstice, June 21st, 6 planets. Well, we're going to take another interesting point that you can find is the Pleiades, which are right here. The Pleiades, the 7 sisters, usually we can only see 6 of the 7 sisters, but a little earlier in the morning, depending upon how low your eastern horizon is, the lower the better, so that you can see the Pleiades when it's a little darker out, but binoculars will be a great help, and it's kind of neat that we have the Pleiades and Venus and Mercury all kind of working together. This is, again, the morning of June 21st around 4:15. Next slide, we're going to jump ahead to June 27th. So on June 27th, one of the neat features is, notice the moon has left Jupiter. The moon has slid along the ecliptic because we're 6 days further along. The moon moves against the background of the stars from west to east. And now we're down to Venus, and this is going to be a great morning to be able to find the planet Mercury, because you see that Mercury is really close to the moon, and the moon is going to be very slender crescent. Binoculars will help you find the moon and the elusive planet Mercury. Just a lot of fun to find Mercury. Most astronomers haven't even seen Mercury naked eye. It's kind of like a neat project to find. And it will be available in the morning sky for a week or so, either side of June 27th. So that's the morning sky with some planets. Now let's look at the evening sky. And we're going to check out some constellations in the evening sky. And what we're looking at here in the evening sky, as the stars come out on this next slide, we see Antares that I was talking to you about. This is at the heart of the Scorpion, and Antares means I'm not Mars. It's reddish, about the same brightness as Mars is. We'll get back to that in a moment. Hopefully you remember from previous shows how to find Arcturus. Arcturus is kind of the spring to summer transition star. Among the 5 brightest stars in either hemisphere, Arcturus is a magnitude 0 star. Reddish orange, it scintillates, it flames, it looks awesome through a telescope or binoculars. It looks awesome just looking up at the sky at it. Remember, you're going to take the handle of the Big Dipper, you're going to arc to Arcturus, and you can't miss it because it's reddish orange. It's the brightest star in the overhead position. You're going to arc to Arcturus and spike down to Spica. Spica is a magnitude 1, so it's about 2.5 times dimmer than Arcturus, but it's a blue-white star, and it's just so beautiful to look at, again, through binoculars or a telescope or just naked eye. Take some time to notice stars have color, and it's just awesome. Then I already mentioned to you Antares. The neat thing about Antares in this time of night, this is 10 o'clock, and we happen to be at 10 o'clock at night, and this is towards the end of June on any given night. Antares is a magnitude 1, same magnitude as Spica, but the neat thing about them being the same brightness is you can definitely compare the color, the reddish color of Antares and the bluish-white color of Spica. Very, very cool. And then down below, this that looks like a kite, that's a very cool constellation known as Corvus, the Raven. And that's Arcturus down to Spica, and then a little bit below Spica, look for that kite shape here. And that is, so we can go on to the next slide. We'll show you some of the artwork here. Arcturus is in the constellation of Boötes, the herdsman. Spica is the brightest star in the constellation of Virgo, the virgin. And the star Spica usually represents a sheaf of wheat, an ear of corn, sometimes the ring on her left hand. Keep on going, and there's the raven, Corvus the raven. Now, when you come down from Arcturus to Spica and you turn to the other side, you're going to find out that you have Antares. And Antares is a great star, reddish as I mentioned. It's the heart of the scorpion. Scorpio, I should say Scorpius, the scorpion, Antares is at the heart. And as you look a little bit to the right, you see two bright stars that are really close to each other in brightness. And these are the stars of Libra, Zubin el-Ganubi and Zubin el-Shamali. And the neat secret about these two stars is that these stars were once part of Scorpius, the scorpion, because Zubin el-Ganubi means southern claw and Zubin el-Shamali means northern claw. So the claws of the scorpion used to come out to here and here, but Julius Caesar cut off the claws, shortened them so he could have his own constellation, the scales of justice, Libra. How cool is that, making up your own constellation? So those are some neat things that are happening in the morning sky with the alignment of the planets. Don't miss the solstice, June 21st at 5:13 a.m. And then great constellations as always. It's the night sky, it's the greatest show on earth, and you can see it in your own backyard. I'm Dave McDonald for The Sky This Month.